So let's talk about saving for the future, a really important thing for your peace of mind. We are going to focus primarily on growing money. So when we talk about growing money, these are kind of our objectives. So we want to understand why it's important to save for the future. And I hope that's obvious that we need to pay for short-term and long-term needs. So things like vacations and bills and unexpected emergencies, education, all those types of things, cars, houses, retirement. So that is why we need to save for the future. We're going to talk about extensively how money grows, and we're going to do it talking first about simple interest calculations and then compounding interest calculations. So as it relates to savings accounts or borrowing money, how do we compute interest from a simple perspective and a compounding perspective? And then we'll briefly touch on some places where you can save. So with that said, I want to start by talking about growing our money. So let's flip real quick to chapter 9, where we will talk about computing interest, because that is one of the easiest ways to try to grow our money. So interest is the money that is paid by a financial institution for the use of your deposit in a savings account. So if I deposit money, they're going to pay me interest because they're using that money on their own to loan out and do things. Or interest also can be the amount that I'm paying when I borrow money from someone, from a bank, from a relative, from someone like that. So in the case of this loan, it is computed based on simple interest. That's terrible. All right, let's talk about saving for the future. When we talk about saving for the future, there's many ways we can do it. We can do it by putting money in a savings account, money market accounts, the stock market, mutual funds, etc. We're going to focus in this chapter primarily on savings-related accounts. And the thing that's important to us is that we want to grow our money. So there are really two important objectives related to that I want to talk about. And we'll spend most of our time on the second one. But the first one is, why is it important to save? And without going through all those slides, I hope it is obvious to know it is important to save to have security and peace of mind and the ability to pay for short-term as well as long-term needs. So it can be to pay for an emergency that came up, for a vacation, for your electric bill, for gas for the car, whatever the short-term kind of things are, as well as long-term things like buying cars, buying houses, being able to retire, going to college and pay for that. So it has to meet all of those things and give you peace of mind. But the most important thing that we're going to talk about is how to grow your money. And we're going to look primarily at how to grow your money through interest in this chapter. We'll talk about other things when we talk about investing, but for this chapter, we're talking about interest. And we can compute interest and grow our money on a simple basis or a compounded basis. So simple interest method and compounding interest method. And I'm going to flip to the chapter 9 slides to do the simple interest calculation first. So interest is a really important part of growing your money. So to compute that interest, what is it? It is money that's paid by a financial institution for the use of your deposit in a savings account. So I put money in a Fifth Third Bank, and they use that money to loan out to others, to pay things, to do whatever. So they're using your money. The use of that money for them is a cost, so they have to pay me interest on my deposit. On the other side of that, though, is I could have a loan And in case of a loan, interest is the cost that I'm paying to borrow money. So I'm now using the bank's money, so I have to pay them a fee, and that fee is really called interest. So one method is using simple interest. Another method is compound interest. We're going to do simple interest first. So simple interest formula, what is it? It is interest computed only on the amount that we borrow or that we save and deposit without any compounding, no compounding involved. And it assumes that there is one payment made at the end of the loan period. So if my loan is 6 months, I make the one payment at the end of 6 months. If it's 3 years, I make the payment at the end of 3 years. And if I'm depositing money for 6 months, it's for 6 months. If I'm doing it for 3 years, it's 3 years. So it's only one time is the key. So how does this simple interest formula work? There's 3 basics involved. And the first one is the principal. So the principal is the amount we borrowed or any unpaid amount that we borrowed, or the amount that I deposited if I'm on that side. The rate is a percentage of interest you'll pay on a loan. So it is expressed in annual terms all the time. So you'll see it as APY, annual percentage yield or rate. So that is the rate. And then time is the period during which the borrower will repay a loan. It is expressed as a fraction of the year. So if I'll repay the loan in 6 months, it's 6/12 because that's a fraction of a year. If I'll repay that loan in, let's say 97 days, then it's 97 divided by 365. That's how I show fractions of a year, always expressed in terms of a year. So how is this formula computed? So this is the formula, and you'll see most people always refer to it as this, PERTY. I equals P times R times T. So the principal times the rate, which is a annual percentage, times time, which is also expressed in annual terms since the rate is. So for example, we have this one, which is $100 of principal that I've either deposited or I've borrowed, and we're talking for 3 years at 6% interest. What will that $100 grow to, or how much will I have to pay for that $100 that I borrowed? So I equals P times R times T. So I take $100, which is the principal. The rate is 6%. So when converting percentages that it gives you, drop the percent sign and then move the decimal 2 places to the left. So it's 6 right there and the decimal's after it. So move it 2 left. So that would be times 0.06. And then years, since it's in years already, we do 3 divided by 1, and that's our 3 years. And that gets you $18. So that's the $18 of interest I've earned over the 3 years or had to pay. So it's grown to $118. The principal plus the interest is that. So back to the Chapter 6 slides that we're working on. So the amount of money you deposit into a savings account's principal, and then the bank will pay you interest to use your money. And again, we can earn interest on that principal. And as principal and interest grow, more interest accumulates. It is called compounding interest, or interest paid on the original principal plus accumulated interest. So growing money on your money is what a lot of people will say, or interest on your interest oftentimes, and that's what compound interest is. So we're going to show you real quick how that works. So this is that same scenario that we were talking about earlier. We had $100 when we did it under simple interest, and we got an ending balance of $118. But if I compound interest annually in this case, then I'm going to earn interest on the interest. So the year one ending balance that we get, so 100, the principal, times the rate of 6% times the time, just 1 year, because we're doing it annually, is $106. So then I take that $106, and that's my beginning balance for the next year. And then I compute the year two interest. So 106 times 6% is $6.36, and now I'm at $112.36. And I take that one to the next year as my beginning balance, and I take 6% and get $6.74, and I end up with $119. So if you look at how much interest I've earned $19.10 instead of $18, which doesn't seem like a lot when we're only talking $100, but as you start to grow up and you're putting hundreds and thousands of dollars away, that compounding really becomes a huge difference. So I equals P times R times T is really important, and the principal is usually easy for you guys to do, and the rate is easy because it gives it to you. But the time element is the issue typically. So I want to just walk through here with you real quick. So computing the T, if it tells you that it's a 90-day loan or a 90-day deposit, your T would be equal to 90 divided by 365, because there's 365 days in a year. If they told you it was 1 year and 45 days, it would be equal to 410 over 365, which is saying that my lowest amount is days, not years. So I'm talking in days right now. So 365 days in a year plus 45 days more would be 410 divided by 365. So your T would be that. If we were doing monthly then, so monthly we've got 7 months, and that would be 7 divided by 12. If I had 1 year and 2 months, that would be 12 months in a year plus 2 months more, 14 divided by 12. So hopefully you're starting to catch on. If it was quarterly, then 1 quarter is 1 over 4. If it's a year and 2 quarters, then it's 4 quarters in a year plus 2 more is 6 over 4. And if you need to copy this, you ought to. I'll try to put something on Canvas. If it's semi-monthly, that's saying 2 times. That should be semi-annually, my bad. It would be 2 of them and 1 over 2. And if it was 1 year and 1 semi-annual, it would be 2 plus 1 over 2, so 3 over 2. So again, make sure that you realize that should be semi-annual, not semi-monthly. And then the last one is annually. If it's a year, then it's T is equal to 1. If it's 5.5 years, it's 5.5 over 1, so 5.5. Hopefully that makes sense for you to help you on the T calculation. And we'll do a worksheet or two to help you compute these things.